Example 16.10 gives us the graph of a rational function, and it wants us to complete each of the following statements. So these are examples of limit statements, and they are written a little differently than the way that we have in class. Other examples from class have been y approaches something as x approaches infinity would be an example of the way we're writing it in class. So you can see that it is possible to be able to switch the order of the x and the y portions of the statement, and you can also replace the y with f of x. So that way you're specifically talking about the name of a function. So with that said, let's use the statements that are here, and let's analyze how we can use the graph here to help us with these statements. So the first statement says, as x approaches 2 from the right-hand side, remember that this superscript plus means right-hand side. So there should be an asymptote, vertical asymptote associated with x equals 2 if we're being asked to look to the right of 2. So there is a vertical asymptote there at 2. And to the right of the vertical asymptote, I see there's an arrow down here toward the bottom. And I'm going to label that with A because that's what goes with statement A. And we'll see there that the function is headed toward negative infinity with its y values. While we're on the topic of this asymptote, let's go ahead and look at statement D. Statement D says as x approaches 2 from the left-hand side. So that superscript negative means left-hand side. And to the left of this vertical asymptote, we have an arrow that's going up. So that would imply that the f of x values are growing larger and larger. So we'll say f of x approaches infinity there. Let's go back to the top, and I'll label this arrow D. So now let's go back to the top and look at statement B. X is approaching negative 3 from the right-hand side. So again, that statement would imply that there must be something going on here at negative 3, and although we don't see it, we can always draw in the vertical asymptote that would be there at x equals negative 3. And certainly there is an arrow to the right, and there is also an arrow to the left. To the right is going to be statement B. To the left is going to be statement E. And both of those arrows are getting larger in the positive direction for y. So for both statement B and statement E, I will have approaches infinity. Now statements C and F have x approaching infinity and x approaching negative infinity. Those would be analogous to the in behavior. So going off to the right, we have this arrow that's going to be for statement C, and then going off to the left, we will have another arrow here going off, and that's going to be for statement F. Now in a rational function, if one side approaches a horizontal asymptote, then that means that the left-hand side or the other side also has to approach. So we can see here that on the right-hand side, it's starting to flatten as we get further and further out to the right. So we're going to be approaching the horizontal asymptote here at 0, which means on the left-hand side, we are also going to be approaching the horizontal asymptote, which has a function value of 0.